Beachhead subscriptions begin with encryption, as mentioned, a necessary requirement for compliance. But because encryption alone can't protect your data when the password is compromised, there must be protection against those scenarios as John and I described, like when a password is written on a notebook and it's stolen in the computer bag along with the PC. There just needs to be a secondary and perhaps a third or fourth level security mechanism to protect against those circumstances. And Beachhead has such protection. So how do we do it? By leveraging nearly ubiquitous internet connectivity and policy enforcement processes that can happen both automatically at the device level or enforced by administrator action at the console to control access to the sensitive endpoint data. The system begins with a server that resides in the cloud. Beachhead hosts it so our customers have no hardware or software infrastructure to buy or support in their own data center. The administrator accesses the server through a secure web-based console, and John's going to show you what that looks like here momentarily. The Beachhead system is built on the tenet of communications: computing, communicating, and storage devices used by the employees of a covered organization automatically and silently communicate with the server, providing important and dynamically changing information to the administrators through the management console. In the case of a Windows PC, the admin can see when they've last checked in, from which IP address they checked in from, evidence that encryption policies are in order, etc. Most importantly, though, this communication channel allows an administrator a means by which to change use policy and control access to the data on a particular device. This channel allows the administrator the capabilities we described earlier, like revoking authentication or shutting a system down, quarantining the data, even killing all at-risk data. And we're going to show you an example of the quarantine capability momentarily. First, though, let's show you this by means of an animation. Let's say an employee calls and says they've lost their Windows PC in the airport while traveling. It happens all the time. In fact, 600,000 laptops are lost or stolen every year in U.S. airports alone. The administrator for the organization could choose from a number of defense mechanisms, but in this case, quarantine is perhaps our best option. At the next silent check-in, it will get its instruction from the administrator via the server and quarantine the data. This is achieved by the immediate destruction of the encryption key. No key, no ability to decrypt the data from the hard drive, even if the user is able to authenticate or if the computer is already authenticated. The sensitive data is essentially locked down and there's no accessing it. Now let's say circumstances change and the airport traveler finds his PC. The quarantine is lifted remotely by having the administrator replace the encryption key, again, remotely, instantaneously, and once again, access to that data is restored.